Hello and welcome back. This video is about promises in AngularJS. Promises are a way to make asynchronous calls, where asynchronous simply means that you don't get the result immediately. Like when you call a web API, for example, you send a request and you get a response back, but only after some delay. So let's see how promises work and why they're useful. I've already created a new project as usual, so we're ready to start writing some code. Now, a typical scenario is that we want to display something on the page that we get from the controller as a result of calling some functions or services. So let's say we have a variable on the scope called result, and we simply display its value here like this. And then in the controller we define this variable, and let's say that initially it is 5 plus 2, that is 7 of course. We could even have a function called add that takes two parameters, let's say x and y, and return their sum, x plus y. And here we can call this function with 5 and 2 as parameters. That's exactly the same thing, of course. This is all trivial, but don't worry, it gets more interesting. I'm using a simple addition here, but think of it just as an example of any possible operation. This function could be anything. It could be a login function that takes a username and a password and returns a user object. It really doesn't matter. The concept is the same. Now, let's assume that we need to make this call asynchronous, maybe because we need to fetch some data via HTTP and we don't have the result immediately. So how do we pass the result back in this case? We can't use a return statement because we don't know when the result will be ready. The simplest way is to use a callback. So we can add a third argument that is a function, let's call this callback. And when the result is ready, we can invoke this callback function passing the result. So now we need to change the calling code because we're no longer returning the result directly. We need to call add 5 and 2 and then pass our callback function that will receive the result. And inside here we can set the result variable on the scope like this. Right, so we now have a callback, but it's not really asynchronous yet because we're still invoking the callback immediately. To make it more realistic, let's add some delay. So to do that, I'm going to add the timeout service. The timeout service is an Angular-friendly version of the setTimeout JavaScript function, if you like. We can use it in the same way. We call timeout and then pass function and then a delay, let's say 100 milliseconds. And inside the function, we can invoke our callback. Now, to make this delay more visible, I'm going to add a start time variable here before we make the call and set it to now. And then in the callback at the end, I'm going to set an elapsed time variable to be now minus the start time. And then we can display this new variable here in the page. So let's say time is elapsed time. And let's wrap this in some tags. So let's make this h2 so that's bigger and this a standard paragraph like that. So we can see that it took just over 100 milliseconds, which is what we set here. If we change this to 500 milliseconds, of course it will take longer. At this point, let's assume that when we get the result from the first call, we need to make a second call. Let's say that we want to add 3 to the result that we get. So here we call add result and 3, and then we pass another callback that will get a new result, and in here we will set the result on the scope as before, and then close this function like that. So the final result is now 10, and it takes just over 200 milliseconds because it's making two calls that take 100 milliseconds each. Again, this is a trivial example, just adding numbers, but there are many scenarios in reality when you need to make multiple calls in a sequence like this. You could make a login call, for example, and get a user ID, then use the user ID to make another call to get the user preferences, and so on. So let's imagine we now need a third call, and we copy the same code again. Let's say we add 1 this time, and then we set the result on the scope again, and we close this function. And now we get 11 in just over 300 milliseconds. So you get the idea. Each call in the sequence needs a new nested block, and the code doesn't look very nice, even in this simple example. Notice that we're not handling any errors right now. If this add function can cause an error, like if you make an HTTP request, there may be a network failure, then we will need to pass another callback argument to receive the error, let's say error callback, and invoke this error callback if there's an error inside here. And then each time we call the add function, we will need to pass 2 callbacks. So something like this. Another function that receives an error, and we'll do something in here, right? Handle error. And we will need to repeat the same thing for each call. So in this call as well, and in this one as well. As you can see, it gets pretty messy pretty quickly. So this is where promises can help. Let's comment out all this ugly code and see how we can rewrite it using promises. If we use promises, we don't need callbacks anymore. Instead, this add function will return a promise object. And in fact, the Angular timeout service already returns a promise, so we can simply return this. And the value of that promise will be whatever we return in the function that we pass to timeout. So if we return x plus y here, then the add function will return a promise that will contain the value of x plus y. So we can now call the add function like this, add 5 and 2, and we get back a promise object. So what is a promise object? In case you wonder about the name, it's called a promise because we don't get a result straight away. We get a promise of a result, if you like. And a promise object simply has a few functions that we can call. One of them is then. So we can say then and pass a function that will get the result when it's ready. And in here we can do the same thing that we were doing before, that is set the result on the scope and then update the elapsed time so we see how long it takes. And you can see that we get the expected result. Now I've declared this promise variable just to make things more explicit, but typically you would just call then directly on the result of the previous function like this. And that's the same thing. At this point we have a single call and it's still not clear what the benefits are of using promises. It looks pretty much the same as using callbacks, right? But let's go and add our second call. You may think that we need to nest this here and do something like add result and 3 and then call then again and so on. And that will work, but that kind of defeats the purpose of using promises. What we can do with promises is chain them, that is, put them one after another. So we can insert another then step here that will take the result of 5 and 2. And here we can return another promise by doing add result and 3. So let's see what happens. You can see that we get 10 in over 200 milliseconds. So it's making the 2 calls and adding them together. So let's add our third call as well, since it is so easy. We just need to add 1 this time. And there we go, we get 11 and over 300 milliseconds. That means it's making 3 calls. So this is called promise chaining. We are chaining the promises together. And it works because each then function can return a new promise by taking the result of the previous promise and transforming it into a new result. Note that we can also return a direct result if we like, rather than a promise. So here we could just return result plus 1, and that will be the same result, but taking less time because it's making 1 less asynchronous call. And also, we're always using numbers in this example, but we can also return a different type of object if we like. We could add a new step, for example, that returns a string. Let's say we want to generate a string of stars with a length depending on the result that we get on the previous step. So we create an array of length result, and then we join with stars, and this will display a string of stars like that. So we have a lot of flexibility in how we can combine these promises together. Now let's add some error handling. To have a way to return an error in this add function, we need to see how we can create our own promise. And to do that, we need to use the Angular queue service. So let's inject this queue service, and we won't need the timeout anymore. So we can use the queue service like this. We call queue_defer, and this returns an object that we can use to create a promise. So we can use it to return queue.promise. Now we need to replace the timeout function with the standard setTimeout function here, and when we have a result ready, we need to pass it to queueResolve. So this way we've created our own promise, and everything should work exactly as before. Now that we have full control over our promise, we can simulate an error condition. Let's say that we want to trigger an error if the result is negative. So here we calculate the result, that's simply x plus y, and if the result is positive or 0, then we resolve successfully. Otherwise, we want to reject this result. So we can do queue.reject and pass anything that we want, really. So we could pass an error string saying negative value and then print out the result like that. Now the result will never be negative right now, so we get no errors, but if we change this step to add, say, -10, then it will become negative and we don't see a result anymore because an error occurs. So we'd like to catch this error and do something with it. Instead of handling the error for each specific call, we can catch any errors that may occur in the whole chain by adding a catch step. So we can say catch and then a function that takes an object, let's call this failure, and here we can just set the failure on the scope, so we can display this on the page like that. So if we go in the HTML, we can add another row to display the failure. So let's say that the failure is that. And you can see that it says negative value -3 because we get 7 minus 10 is -3. The way errors are propagated down the chain so they can be caught in a single place is very convenient. Frequently, if there's any error anywhere, you may just want to display a message to the user, for example. There's no point in having a separate handler for each call. But if you do need a specific error handler for one call, then you can do that by passing a second callback to the then method. So in this case, for example, we could have a second callback here that receives the failure from the previous step, and if there's any error, let's say that maybe we just want to return 0. And if we save this, you can see that the result we get is 0. So this allows us to recover from an error in some specific instance. One thing to notice is if we remove this special error handler, is that if there's any error, then we don't see the time on the page anymore. And that's because we set elapsed time here in a block that's only executed if everything is successful. Now this is a good example of some code that we always want to execute, no matter if the promise chain succeeds or fails. And for that we can use a finally step. So we can say finally and then pass a function, and here we can set the elapsed time. So if we move the code inside the finally block, you can see that now we get the timing even if there's an error. And it's taking 200 milliseconds because it's making 2 calls before it fails. So we now have a fully functional bit of code that makes 3 asynchronous calls and combines their results and also handles errors and everything. And it's a lot cleaner and easier to understand compared to our initial version based on callbacks. In fact, I'm now going to delete all this ugly stuff and just keep the elegant promises approach. I hope you appreciate how much better this is, and at the same time how powerful it is, because you can combine as many promises as you like in all sorts of ways. And as you'll see, these concepts will be very useful when we look at ng Cordova to use Cordova plugins in an Angular-friendly way. That's all for now, and I'll see you later.